solve the system of equations. And here we have three different equations, and we have three variables, so we can solve x, y, and z. And you could either use elimination or substitution to solve. And I personally like substitutions. That's what I'm going to do here. First off, you can pick any of the three equations, and we're just going to solve for a variable, any one of the variables, x, y, or z. So I picked equation z to start off, and I solved for z by moving all the other terms to the other side, and I got z is equal to 4x minus y minus 6. Now that I know what z is, I can plug it in to z in the other equation. So I picked equation 2. As you see, I replaced z with 4x minus y minus 6. I simplified, applied the negative sign, collected some like terms. And now in this case, you can either solve for y or x. I solved for y. Again, it's kind of flexible in this way. You don't have to do a specific technique. And now I have y. I'm going to plug this into the z equation for y. And now I have z in terms of just x, because this is y in terms of x, and I have z in terms of x. Now that I have these two, I can plug in y and z into our first equation for y and z. And when I do that, look, now all I have is all x terms. I only have one variable, and it's a linear equation, so I can solve now for x. And that's what I do. You have some distributive property going on. You have some collecting like terms, and I'm solving for the variable x, which you'll find is equal to 3. And now, if we know x is equal to 3, we can just plug in x into these equations and get our answer. So y is x minus 2, or 3 minus 2, which is 1. Z is 3 times 3, 9 minus 4, which is 5. And so now this is our solution. x3, y being 1, and z being 5. And so sometimes you could just leave it like that, or sometimes the solution is written like as a coordinate, where the x coordinate, y coordinate, and z coordinate, like that.